finish our discussion of rational numbers, we're going to look at two more operations, and that's multiplication and division. Before we start to look at fractions, let's remember what we thought of when we looked at multiplication of whole numbers. When we saw 3 times 2, we looked at that as 3 groups of 2. So we could say there's a group of 2, there's a group of 2, and there's a third group of 2. So in all, 3 times 2 would have to be 6. We can interpret a problem like 3 times 1/2 in exactly the same way. We can say that we have 3 groups of 1/2. So we have 1/2 plus 1/2 plus 1/2. Now certainly when we have these 3 halves, we could put them together as 1 whole plus another half, which would give us the mixed number 1 1/2, or we could interpret it as the improper fraction 3 halves, which is what you're seeing on the left side of the equal sign with the 1/2 plus 1/2 plus 1/2. Multiplying a fraction times a fraction is a little trickier to see. When we think of 2/3 times 1/4, we could say that that's 2/3 of 1/4, which we can actually show fairly easily using a rectangle model. So here's how that works. Here's our whole, and we need to think about what 2/3 and 1/4 would look like in that whole. 2/3 would be dividing the rectangle into 3 equal groups, and 1/4 would be dividing the rectangle into 4 equal groups. Now let's think about the 2/3. 2/3 would be 2 out of the 3 equal groups of the whole, and 1/4 would be 1 out of the 4 equal groups of the whole. But we want 2/3 of that 1/4. So what we're going to look at is where the shading intersects in these two models. If you think about 2/3 times 1/4, 2/3 of the 1/4 that's shaded in is actually just those 2 rectangles that are in the upper left and then the one right beneath that, the ones that are shaded in both directions. But we have to express our product as a fraction of the whole. So those 2 pieces that are shaded in both directions are 2 pieces out of the 12 equal pieces of the whole, which is why 2/3 times 1/4 is 2/12. Now, we know that when we multiply fractions together, we can also simply look at the numeric fractions and multiply the numerators of the fractions and multiply the denominators of the fractions. So 2 times 1 is 2, and 3 times 4 is 12, which illustrates a property of fraction multiplication. If we're multiplying a fraction a over b times a fraction c over d, that will result in a fraction a times c over b times d. In other words, to multiply 2 fractions, just multiply their numerators and multiply their denominators. Now it gets a little trickier when we multiply mixed numbers. A common student mistake in multiplying mixed numbers is thinking that you simply multiply the whole numbers together and you multiply the fractions together. But multiplying in that way is forgetting that mixed numbers actually are a whole number plus a fraction. So 2 1/4 times 1 1/2 is really 2 plus a fourth times 1 plus a half. Now if you look at that from your algebra point of view, you may see 2 binomials, and you know that when you multiply 2 binomials in the world of algebra, we call that method of multiplication foiling. It really means we're using the distributive property. We need to multiply the 2 times the 1 and the 2 times the 1/2. We need to multiply the 1/4 times the 1 and the 1/4 times the 1/2. And when we simplify, we end up with 3 3/8. Now that's a lot of work to do to multiply 2 mixed numbers together. So there is another way we can multiply two mixed numbers, which is to rewrite them as improper fractions. And if we do that, then we can simply multiply the numerators and multiply the denominators. And if we rewrite the 27/8 as a mixed number, we get the same 3 3/8. Now, dividing rational numbers is a little tricky to see too. So what we're going to do is look at a division problem that has whole numbers in it and try to reinterpret that division so that it applies to division of fractions. So let's start with 6 divided by 3. We could interpret 6 divided by 3 as taking 6 objects and looking to see how many groups of 3 are in those 6 objects. Now that's a little different than the way we've been looking at division. We've been saying 6 divided by 3 is 6 objects divided into 3 groups, and that certainly is still a good way to interpret division. But for our purposes right now, let's look at this in the other way, which is to say, if we have 6 objects and we're dividing by 3, how many groups of 3 can we get out of that? Well, we could get 2 groups of 3, so 6 divided by 3 is 2. How about 6 divided by 2? Well, if we interpret it this way, we would say how many 2's, how many groups that have 2 in them are in 6. So that's 1, 2, 3 groups that have 2 in them. So 6 divided by 2 is 3. Now the reason why we're looking at division this way is because we want to extend this thinking to 6 divided by 1/2. So there's our 6 objects, and if we're dividing by 1/2, we want to know how many groups we can get out of this that each contain 1/2. And in order to see groups that contain 1/2, we have to divide each whole into halves. And if we count up the number of halves we have in 6, we'll see that we have 12 halves. So 6 divided by 1/2 is 12. Now this illustrates another common misunderstanding that students have, which is they think that when you divide a number by another number, you always get something that's smaller. Obviously that didn't happen here. We took 6, we divided it by 1/2, and we got something bigger than 6. The reason for that is that we were dividing 6 by something that was less than a whole. So we were taking these wholes and dividing them up into smaller parts, and that created more parts. How about 6 divided by 1/4? How could we show that? Well, that would be 6 objects, and we want to know how many 1/4 are in those 6 objects. So we have to divide the 6 objects into fourths and then count the number of fourths we have in all. There are 24 fourths in our picture now. So 6 divided by 1/4 is 24. So can we take this same thinking and apply it to a problem where we have a fraction divided by a fraction? And as it turns out, we can. So let's think about 1/3 divided by 1/6 as asking how many 1/6 are in 1/3. Well, there's our whole, and there's 1/3. Now we want to know how many 1/6 are in that 1/3. So we need to be able to see how many 6 there are by dividing our whole into 6 equal pieces. So now concentrate on the yellow part. That's the 1/3. How many pieces do you see in there that are a size of 1/6? There are 2 of them. So 1/3 divided by 1/6 is 2. Now we know that when we divide fractions, that we can always rewrite a fraction division problem as a multiplication problem. We do that by leaving the first fraction as it is, and then multiplying by the reciprocal of the second fraction. In the problem we just did, we found that quotient by looking at a model. But if we had used this property of division, we could have said that 1/3 divided by 1/6 is the same thing as 1/3 times 6/1, which is 6/3 or 2. Now let's look at a problem that involves fractions, but actually the first time we look at it, we're not going to use fractions. We're going to work up to the fractions. So here's the first part that has whole numbers in it. Jane has 20 yards of fabric. How many blouses can she make if each blouse requires 2 yards of fabric? So think about these 20 yards of fabric. She's dividing the 20 yards into pieces that are 2 yards long. So the 20 yards of fabric divided into pieces that are 2 yards long would give her 10 blouses in all. What if she still has 20 yards of fabric, but now she wants to make blouses that each require 2.5 yards of fabric? Well, now she's going to have to take that 20 yards and divide it into pieces that are 2.5 yards long. So we need to find out what 20 divided by 2.5 is. Now 2.5 is a mixed number, so it might be easier to think of 2.5 as 5 halves. And in fact, it might be easier to think of the 20 as 20 over 1. That's because we know we can rewrite this division problem as a multiplication problem by saying 20 times 2/5. And now we can multiply these two fractions by multiplying numerators and multiplying denominators and then simplifying, and we have 8. So she can make 8 blouses. Now let's look at that visually. Let's say that this is the 20 yards of fabric, and we're going to start cutting off pieces that are 2.5 yards long. So the first cut is at 2.5 yards. The next cut's at 5 yards, then 7.5, then 10, then 12.5, then 15, then 17.5, and now we have exactly 2.5 yards left to make our last blouse. So if you cut up or add up the pieces we have now cut this fabric into, you'll see we have 8 pieces. Now what if the blouses take just a little bit less fabric, only 2.3 yards? How many blouses can she make? Well, she's still starting with 20 yards of fabric, and we're dividing it into pieces that are 2 1/3 yards long. So we need to know what 20 divided by 2 1/3 is. That's 20 divided by 7/3, which is 60/7, or 8 4/7. So, to answer the question, how many blouses can she make? She can make 8 blouses because the 4/7 does not represent an entire blouse. It's leftover fabric. Let's take a look at a picture of that. There's our 20 yards of fabric, and we're going to make cuts every 2 1/3 yards. So there's the first cut at 2 1/3 yards. The second cut is at 4 2/3 yards. The next cut is at 7 yards. Then 9 1/3. Then 11 2/3. Then 14. 16 1/3, and 18 2/3. Now if you look at what's on the end, that's a little piece that's not big enough to make a blouse out of. So we've got 8 whole blouses. But there is some fabric left over. So how can we figure out how many yards of fabric is left over? Well, now if you look at the picture, you might be able to see we've got 1 1/3 yards left. If you look at the result we had when we did the division, we had 8 4/7. So we have to be a little careful here. That 4/7 does not mean 4/7 of a yard. It's 4/7 of a blouse. So she used she used 2 1/3 yards for each of her 8 blouses, which was a total of 18 2/3 yards. The fabric that was left was what she had left over from the 20 yards. So 20 minus 18 2/3 is 1 1/3 yards. So the amount of fabric that was left over is 1 1/3 yards. So that's the end of our discussion of fractions. You'll get a chance to practice some more fraction operations in class.